everyone. I'm just going to wait until, hello, everyone. We're just starting. I'm going to just let some people trickle in. Welcome to today's webinar. My name is Ash McCaskill. I'm the programs coordinator at AgeWell and for the Epic AT platform. Just before we begin, I just wanted to share some access points. So please note that today's webinar is being recorded and will be available on the AgeWell YouTube channel after the event. There is closed captioning available. So if you just look at the bottom of the window, you'll see that closed captioning. You can just put on show captions and that will be on. The next thing that I do want to say is just to make sure that everyone has a good experience today. We really do expect that all speakers and attendees show kindness and respect to everyone in this space. So if there's any form of harassment that is being shown, I will remove that person from the event. There will be a Q&A at the end of the event. So what I suggest is that you use the Q&A box, which is found at the bottom of the Zoom window, to put in your questions. And you can also put it in the chat if you want. I will be moderating those questions. And we encourage you to use the chat. So tell me where you're coming from today. I'm coming from Montreal. It's a rainy day here. So where are you coming from today? Put it in the chat. Yeah, I would really love to welcome you to the webinar today, which is on Digital Ageism, Challenge of Modern Times. And I'm so excited to be introducing our speakers today, who are very, very important people to the AgeWell Network and the Epic AT platform. So I want to start off by introducing Dr. Charlene Chu, RN, is an assistant professor at the Lawrence S. Bloomberg Faculty of Nursing at the University of Toronto, and an affiliate scientist at KITE Toronto Rehab at the University Health Network. She is cross-appointed status only with the Factor Inwintash Faculty of Social Works Institute of Life Course in Aging, as well as the Rehabilitation Sciences Institute at the University of Toronto. She is an assistant editor at the Canadian Journal on Aging. Her research is focused on technology-enabled interventions to support the quality of life of older adults and caregivers in post-acute care settings, with a particular interest in co-design, long-term care, and the community. She is an accomplished early career researcher, very accomplished, and I say that with a lot of passion. She's our ECR Epic 8, one of our ECR Epic 8T recipients, who is funded by the Tri-Council agencies, CIHR, SHRC, NSERC, NFRF, and the Alzheimer's Society of Canada. Dr. Chu has published over 65 manuscripts since 2012, holds 2 patents, and Dr. Chu co-authored 2 book chapters about ethics and informatics for nursing practice, and published multiple papers about the ethical challenges of various technologies, as well as digital ageism, which we're going to be talking about today. The next speaker, who I'm just as esteemed to introduce, is Dr. Shehroz Khan. He is a scientist in artificial intelligence and robotics and rehab lab at the KITE, Toronto Rehabilitation Institute, University Health Network, Canada. He is also cross-appointed as an assistant professor at the Institute of Biomedical Engineering, University of Toronto, Canada, and he holds a PhD degree from the University of Waterloo, Canada, in computer sciences with a specialization in artificial intelligence. Dr. Khan's main research focus is the development of machine learning and deep learning algorithms with the realms of aging, rehabilitation, and intelligent assisted living. As a principal investigator, PI, or co-PI, his research program has been funded through several Canadian, US, and other international and industrial grants. He has published 75 academic papers in top international journals and conferences that have garnered more than 3,700 citations on Google Scholar. He is the founder and organizer of the peer-reviewed international workshop on artificial intelligence for aging and rehabilitation that is held in conjunction with top AI conferences since 2017. So I do really thank you both for being here, and I thank all of you for being here today on this, what is a rainy day in Montreal. I hope it's great where you are. I will pass the mic to my esteemed colleagues, and thank you so much again. Have a great webinar.
Thank you so much, Ashley, for reading out our full biographies. Thanks everyone for joining. I can see from around the world and across Canada. That's wonderful. Thank you so much for taking an interest in this work. And again, I just want to start off by thanking Ashley and Sam from AgeWell for the invite for us to share our research here that we've been doing over the last 2 years. So this presentation is really meant to facilitate discussion and encourage questioning, especially some of these taken for granted assumptions that we have about aging and technology use for older adults. And so this work aims to really foster connections between theory and conceptual frameworks, as well as technology development, policy, practice, and ultimately we hope that this work will result in more, digital equity for older people. Next slide, please. Next slide. Thank you. So I'm not going to go into my bio because Ashley did such an amazing job. I'm Charlene. This is Shehroz. We worked together for several years now. We're actually both HQPs with AgeWell. So we have several funded projects together, including this one. And so I perhaps want to also say that we work with an amazing interdisciplinary team. I give them absolutely full credit in the work that we've put together here today. And you can see the interdisciplinary team we have that is comprised of people in computer science, critical gerontology, philosophy, law, and bio, and a bioethicist. Our research assistants are all interdisciplinary as well. So from health as well as computer science. And so the work that we'll be presenting here is our project that's funded by SHRC and partnered with AgeWell. So next slide, and Shehroz, why don't you take it from
Thanks, Ashley, and thanks, Charlene. So today we are going to touch upon these four broad areas. Firstly, I'll talk broadly about the general biases in AI. I know even this discussion is around ageism, but I think it is also important for us from an education point of view to understand what kind of biases are out there. And you will be surprised, like we are, that how much biases are around us and how do they influence these AI algorithms, right? And then Charlene is going to talk a little bit in detail about our research on the digital ageism aspect. And then I'll also try to summarize very quickly some of the technical challenges that we have taken, and we're trying to resolve this problem on our end. So, in recent years, AI, everybody is talking about AI. There's a lot of enthusiasm. There is a lot of excitement about artificial intelligence in general. But then at the same time, you may also see these types of news clippings, and I just took it from the popular media. And then you can see there's a lot of concerns about, hey, oh, the AI is racist and sexist and creepy, and people are getting arrested, and then people are thinking about models in a particular way, and it's a very weird word, I would say. But then like today's focus is more on the ageism, so we're going to focus more on that. But I think it is important to see how AI can be portrayed in the media. Now, when we talk about bias, what is actually a bias? So bias may refer to any systematic and unfair favoritism or discrimination shown by an AI system towards certain groups or individuals or communities. And why this is a problem? Because it can lead to inequalities and discrimination, and it further reinforces the the biases that are contained in the data that are collected by the humans. And it can lead to unfair outcomes, where certain groups can be systematically disadvantaged or excluded from the opportunities. I think that is the biggest fear, and that is the bigger problem. If we are building these fully automated systems, then how we can control that these kind of problems do not occur. So why AI can be biased, like you would think, and this question may come up. Why artificial intelligence? Artificial intelligence is not a person, is not a person or an individual growing up in certain circumstances. So why this machine can be biased? And I think it is easy to understand, because AI algorithms in itself, they are mostly some mathematical functions or operations, and you're training these algorithms on human collected data. Now, human is in the loop, and that can lead to biases. The human biases. I'm a person, I may have my own biases, and those biases may go into the data that I'm collected, and those data can influence those algorithms. So this is a very nice picture by Merabi et al, and you can actually see that this is kind of a vicious cycle. All of them feed to each other. So you have a bad data leading to bad algorithm, leading to bad user interaction, leading to biased data, and it keeps on going. And so this is a major problem. And this is I think, if we have engineers in this audience, I would like them to think and take a moment that before developing your AI algorithms, have you checked out some of these boxes? Do you even know if your data is not biased? And I'll give you some examples moving on. So, okay, let's begin with some interesting visual kind of examples. So uh, AI, any AI algorithm by default does not know different concepts. So an AI algorithm will know that the picture on the left is a cat or on the right is a dog. You have to provide some labels to it. So you have to provide hundreds and thousands of or millions of images of cats, and you have to provide these labels: cat, 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 and then dog, dog, dog. And then the expectation is that over a period of time, if the algorithm has seen sufficient images, then it will identify whether this is a cat or a dog. But what if I switch the labels, right? If I start calling the image on the left as dog and the image on the right as cat, the AI algorithm will will start learning that the images on the left are dog, right? And this happens a lot. Mislabeling, maybe because of bias, maybe because of our own ignorance, maybe because of our non-awareness, we can do this. And the moment we do this, we create dirty data. And there's a lot of dirty data or rogue data available. And I believe these slides may be shared, or the presentation may be available online. So I would highly encourage you to watch this YouTube clip. It's an 18-minute video. It's a TED Talk, and it talks about these different biases that can creep in. And I have borrowed some of the ideas for today's presentation from that presentation as well. Okay, now I'm going to quickly give you some examples of different types of biases. So what is an interaction bias? Interaction bias is, okay, you feed lots of images of cats to an AI algorithm, and you say that, okay, all the cats have hair, right? So over a period of time, the AI algorithm will train itself and to identify cats. But then that algorithm will not be able to detect this cat, which does not have hair and looks very creepy as well. Now, these are some results that I did Google search by myself. I just searched for doctors. And what I saw is that I'm just showing some of the like the top 4 or 5 images. As you can see, that most of the doctors, that the images that came out were actually men. And this is kind of a latent bias, which actually kind of indicates that women cannot be doctors, or there are less women doctors and they are not equally represented. Another type of bias is called selection bias. I searched for a group of people, and what I found were many images. And as you can see, this is actually showing a group of people, light-skinned people, mostly younger people, even though male and female, men and women are kind of equally represented, but then age kind of thing, you can see there are no older people in here. So these are the different types of biases that exist. And from an academic point of view, Mehrabi actually classified these biases into these three categories: data to algorithm, algorithm to user, and user to data. If you recall the previous image that I showed, and these are all important because they form a circle and they feed on to each other. So it is, and I would highly encourage, if you're interested in reading papers, then you should read this paper that I showed on the bottom right. It's a nice review paper. It is not very technical. It reads like a story, and it's very educational in the sense that there are many types of biases that exist that most of the time we don't even know. Okay, so some more pictures. I like to show pictures. So you may have heard about in the last 6 to 8 months about these large language models, ChatGPT. It's everybody's talking about this. So what these ChatGPT and other models are, they are generative models, and they are trained on huge amounts of text and images, and you can actually generate different types of, like you can do a Q&A, you can generate new images and stuff like that. So there is a similar website called Hotpot AI. I went there and I wrote this query that draw me a picture of an astronaut dog eating a carrot, right? A very weird hypothetical image. And it actually gave me a fairly interesting image. I've never seen such an intellectual dog in my life, eating a carrot especially. Now, for fun point of view, from that point of view, it's good. I can generate any idea, and it will give me multiple options. But then the problem is, when we go beyond this, when we are going beyond an astronaut dog and we go to the real world problems, then what happens? So there's this very nice article that was published, I think this month in this The Conversationalist. Again, I would suggest you to please go and read this article. But I'm summarizing what they did. Actually, I wanted to do this, but then this person already did it, so I just said, okay, I don't have to repeat the same thing. So Midjourney is another very famous generative model where you can generate actually very realistic images. So what they did was, the author actually searched for images of non-specialized job, and what they got was images of younger men and women. And when they searched for specialized jobs, they got younger and older people, but older people were always men, right? So which indirectly implied that women can only do non-specialized job and not a specialized job, right? So you can see a complex interplay of ageism and sexism happening at the same time. They searched for journalists, reporters, and correspondents, and what they found was mostly the images the Midjourney generated were people, light-skinned people. And most of those images were very conservative appearance, like none had tattoo, piercing, or unconventional clothing. And many people wore button shirts and ties. So again, showing men kind of dominated appearances. And those appearances maybe, I don't know, maybe good for TV presenters, but for journalists who are on the field, are they always wearing t-shirts and ties? Who tells them to wear a particular type of dressing? So you can see this classism and conservatism kind of thing happening within these generative models. There are themes around urbanism as well. Like, so most of the images that Midjourney generated were urban environments with skyscrapers and large city buildings and newer constructions, whereas more than 40% of the present world population lives in rural areas. So you just excluded them. You just presume that everybody is living in New York or Toronto or Vancouver, which is absolutely wrong, right? So these types of biases exist without us realizing that what is going on. So over to Charlene, and she'll talk about our research on this topic.
Thanks, Rose, for the overview. So let's turn our attention to ageism here. So ageism is defined as a societal implicit bias that refers to the stereotypes, prejudice, and discrimination directed towards others or ourselves on the basis of age. And I can see from our participant list, we have some advocates against ageism here, so I'm not going to go too far here because I'm aware that most people will understand the concept of ageism. Could you click, Shehroz? And so ageism is reflected in individuals as well as our systems. And could you click again? Thank you. So ageism is a pervasive structure of injustice with severe impacts on those affected. So it diminishes older adults' access to healthcare, employment. It can exacerbate social isolation, social exclusion. It restricts, the ability to express, sexuality, for example, and may also increase the risk of abuse and exploitation. So last year, the WHO came out with this policy brief in February of 2022 about ageism and AI for health. And in this, they say to ensure that AI technologies play a beneficial role, ageism must be identified and eliminated from their meaning AI technologies, design, development, use, and evaluations. So because digital technology and AI often can mediate ageism and reinforce its negative impacts, according to research, older people are often assumed, including on themselves, to be less capable of using and enjoying new technologies, and they're frequently excluded and ignored in design practices. And ageism affects how data on older people are collected, compiled, and this is all according to the UN Human Rights Council as well as the WHO. Next slide, please. So due to the proliferation of AI technologies and the increased risk of AI entrenching or even exacerbating some of these ageist beliefs that are within society, we decided to critically examine the presence of age-related bias in AI systems. So our research here focused on developing some theoretical insights about age-related bias in AI. And then we really wanted to explore how some of these age-related biases may be encoded and executed and amplified through these AI systems. And so the first there being more conceptual in nature. So what's a framework? How does this actually work? How does ageism seep into how we design and develop and deploy technology? And then secondly, can we then focus in a bit more and actually pinpoint how it creeps in using some of the earlier thoughts around this problem. So this is a project that was funded by Shehroz. Sorry, thank you. This was a project that was funded by Shehroz in 2020. So this is work that we've been doing over the last 2 years or so. And our partners here are AgeWell as well as U of T. Next slide, please. And so I just wanted to highlight this because this continues to be an increasing awareness of this issue. Even just as early as last week, there was an editorial that was in the Lancet Digital Health about the call for digital health equity for older populations. And then last month, there was a book that was called Digital Ageism that was released by colleagues from Spain that was edited by Dr. Rosales and others. And there's really, really amazing, beautiful work here as well for anybody to explore. Okay, so for our first objective, where we wanted to develop some of these conceptual insights, so we published this article in the Gerontologist, and in this paper, we talked about digital ageism, and we referred to it as age bias throughout the design, the development, deployment of technology and AI systems. And we refer to the entrenched and inherent ageist tendencies in our society that essentially are able to creep in and are then amplified by some of our technological infrastructures. And so this includes, the process of growing old in an increasingly digital world that directly reinforces digital inequities, exclusion, and marginalization. And we also point out that digital ageism is supported and reinforced through our socio-technical systems. Next slide, please. So feel free to check out our paper. So as part of this paper, we came up with this framework and this conceptualization. We based this on some work from Whittlestone, and Whittlestone's work conceptualized a framework as a way to identify AI bias within a broader society. So we adapted her framework and really applied it to digital ageism, so age-related bias within a broader society. So here we have identified different ways in which ageism infiltrates technology, design, and use, and then sort of the ways in which it can encapsulate a variety of different processes that then reinforce ageism within society. So I'll go through each of these quadrants one by one, but basically here, what I want you to take away from this is the cyclical nature of this framework that really underscores how digital ageism is sustained through ageism within our society, how it's encoded and then amplified through our technologies here. And we term these the cycles of injustice that contribute to digital ageism, because we do see this as a major problem and contributing to social injustice. Next slide, please. Okay, so I'm going to go through each of the quadrants of the conceptual framework. So I'll start here of representation. So this is speaking towards social representation within our society. So the ideas here around the age scripts from a societal representation of older adults. This word cloud here actually was created by an Australian research group that asked in a survey, what are the perceptions of older adults? So these are some of the words that represent the answers that they received to some of their survey questions, a national survey question. And so alongside some of these assumptions around older adults and some of our stereotypes, the idea here is that older adults can be, not as technologically savvy, that they're, in this constant state of decline, because we tend to view aging as with this biomedical lens, this biomedical focus that leads us to then really focus on age-related problems and health-related problems, as opposed to things like joy and leisure and other aspects of aging and other aspects of growing old in our society that are highlighted in younger populations, but not so much in older populations. Next, please. And so I just want to also point out that each of these quadrants are not completely encompassing in nature. We had a limited amount of space, but these are examples in each of these quadrants just to demonstrate the idea. Okay, so then this leads into the societal representation of older adults, leads into the design of the actual technology. So here, this is about the ways in which technology is researched, developed, designed, deployed. And here we can see that it's the teams and the people who will then bring some of these ageist stereotypes. And this isn't purposeful, it's not intentional, because if you remember the definition of ageism, ageism is implicit. So we come with these stereotypes that we don't even realize that may be forming the basis of some of our decisions. A scholar in the area, Ruha Benjamin, who talks about race in AI, she would say here, and she wrote about how there are no accidental design choices. So when we are designing technology, we always have a user in mind. We have a problem in mind, and then we design for that problem for that user. And so just in being able to say that, that means that every design choice is intended for someone. And so that imagined user is based on a string of assumptions. Throughout our research processes, we also often will exclude older adults. There is research to show that sometimes when older adults are even included, it can be, at the very end, they're once the product is already developed, for example, it can be superficial in nature, limited in scope. The word tokenism has been thrown around as well. So there isn't a true inclusion of older adults. And so we're not embedding their perspectives in the product, as well as the teams, because the teams that also develop the technology can also be quite ageist as well. And then we also, not yet. Thank you. And then we also have incentives. So the incentives here refer to capital incentives, economic incentives. So when we think about the med tech space, it's a multi-billion-dollar space. And when we are thinking about what technologies are developed for older adults, often they're technologies that might be easy to market because they're based on a health-related problem. When we think about our research, our development, what are the problems and what are the areas of aging that receive the most funding? Often they are deficits in aging, health-related issues. And so then again, you're having this proliferation of technology that is being developed for older adults, but really within the space of health, as opposed to much more broader and more holistic. And I just also want to point out here that there are other research papers have been written around the kind of the Silicon Valley kind of culture of technology development, and the culture of kind of move fast and break things, but we don't really quite think about the people who we are breaking. And so there is a kind of culture around technology development as well that is and has been shown to be ageist in research. Next, please. And then we have the resultant technology that is then developed. This technology is not always well suited to the physical needs of older adults because their needs and their wants and perhaps their preferences have not been taken into consideration. So for example, manual dexterity can perhaps reduce an older adult's ability to use and enjoy the functionality of various digital technologies. This also encapsulates the data that is not captured. So then what ends up happening is this technology is focused towards a certain group of older adults. We know that older adults are incredibly heterogeneous, but the technology that is developed is focused on a small group of people. Then the data that is collected is only representative of this small group of people. And then we're not capturing the aging process or what it actually looks like for older adults otherwise. So we are excluding huge swaths and then only really focusing on a narrow population of older adults. Next, please. And so then the harms are what we call allocation harms here. So the definition of AI bias very traditionally is a system that discriminates unfairly if it denies an opportunity or a good, or if it assigns an undesirable outcome to an individual or group on grounds that are unreasonable or inappropriate. So here we have examples of resource allocation, which can directly and unfairly deprive older adults of valuable resources like healthcare, like job opportunities, for example. There's been literature to show that ads are not targeted towards older adults if their data indicates that they are above a certain age, and then this can trickle down into other aspects as well. So here you can see that if we have less technology that is more user-friendly and targeted towards older adults, that we're less likely to really capture a larger group of older adults. That's fine, go on. Thank you. So as part of this work, what we did was, again, referring back to the idea of allocation harm and social capital, political capital, we looked at a repository that's called the AI Ethics Guidelines Global Inventory. And so this is compiled by Algorithm Watch, and it's about fair and transparent ethical use of AI. And it compiled a variety of different documents that are really focused on ethical AI. And so at the time when we did this, there was 146 English documents, and we combed through these documents and we found that only 23% of these documents even mentioned age as a type of bias. So here we can see that even when we're talking about the need for guidelines to highlight fairness as a key governing principle in AI, that that age as a part of this broader conversation is often neglected. Next, please. In addition to developing some of these conceptual insights, we continued to dig a bit deeper into our conceptual framework. And so we actually wrote a book chapter. It's called Digital Ageism, Algorithmic Bias, and Feminist Critical Theory. And so this is published in Feminist AI from esteemed scholars in the field, Jude Brown, and et cetera. And this is a really interesting book. If you have time to pick it up, it focuses on excellent work from scholars from the University of Cambridge, Oxford, Google Research, et cetera, and really applies feminist scholarships and to really hold developers of AI accountable. When we move into how is digital ageism then encoded into processes of and AI technology and the processes of developing AI. So referring back to Shehroz's earlier slides, looking at the Merabi cycle of AI bias and different kinds of bias. So in this paper, Merabi will identify, I believe, 10 different kinds of AI bias. And so what we did was we conducted a scoping review of the academic literature as well as the gray literature, and we included 49 research studies from academic literature and 25 pieces from the gray literature. And so you can read our research protocol that was published last year. And so our paper has been recently accepted, and so it should be published in Nature, Social Science and Humanities. And so what we found is that the most common AI applications that intersected with age were with respect to age recognition and facial recognition systems. And then the most frequent types of machine learning algorithms were CNNs and support vector machines. When we looked at where did this ageism and where did this kind of bias occur, what kinds of bias were most common, we found that they most appeared in this data to algorithm phase. So early on in the cycle where it was the data that was biased that was leading to algorithms. This was then followed by the algorithm phase, where we actually found some examples of models and algorithms that were then modified and either amplified age-related bias. And then lastly, we had user to data. So this was with respect to the actual user, how they interacted with the technology, and then that led to different kinds of data. And what we found also that's worth mentioning here is that the majority of academic publications, they really talk about more than one kind of bias. So whether that be with respect to representation bias or measurement bias. And so there is many different kinds of bias that are highlighted. So there's lots of different areas that we could target to try to address this issue. And one of the main takeaways from this paper is that it's likely between the data and algorithm stage where we can really focus on some of this attention. Next, please. In another paper that we have in process at the moment, what we did was we looked at, we know from our work that the most commonly used data sets for facial recognition were these 7 different facial image data sets. And when we analyzed the breakdown of these 7 different data sets, and you can see them here on the screen, the names of the data sets are at the top, GNet, academic morph, morph longitudinal, etc. So you can see here, for example, morph longitudinal, which is kind of in the middle of your screen, that in this, it's the largest data set of its kind. So there's over 400,000 images of people. And when we looked at how older adults were labeled, we can see across the board that there is no consistency in how older adults have been labeled: 50 plus, 70 plus, 61 plus, etc. And so again, there's this aggregation bias that comes to fruition here. Then when we move down one more row, we can see that the number of images in that labeled category of older adult. So even in the largest one, which is morph longitudinal, we have 0.001% of images that represent the oldest demographic, and that's defined as 70 plus. And so that kind of varies across the board, but the vast majority are well and below the representation of the general population in any kind of global demographic population. So, and you'll also notice very wide age gaps here as well. Next, please. And so this is a graphical representation of what I just described here. And what I've highlighted here in yellow is along this tail end that you'll see very little, you'll see very few data pieces here. And so again, representing a very large group, but then a very small amount of data. So how do we start addressing some of these issues that we've highlighted here? So we have, I think, principles of digital equity will be really helpful here. So digital equity is the social justice goal of ensuring that everyone in our society has equal access to technology, the tools, and the digital tools and the internet as well, that everyone has equal benefit to these things. And so when we talk about this, and referring back to the earlier framework that I presented, we need to have a more participatory design. I think this is something that AgeWell does quite well, where we have the involvement of older adults in the development, the design, the deployment, but it really takes a team that is multifaceted and that is interdisciplinary to be able to pull this together and get feedback from multiple players here. And so this is something that goes across sections, across disciplines, including private, public, research, health, technology, ethics, so on and so forth. The second would be improved digital infrastructure and framework regulations that would help empower people to make sure that we have more technologies that are developed more ethically. And so here we really need a culture change in order to support regulations that would help govern transparency and accountability of AI bias. AI more recently has been painted as this existential threat to humanity. So I think, again, this underscores why it is so important to have more focus on, broader structures that can help us govern this. And then we move into increased data representation as well as a representation on teams. So here we need to make sure that the data is not only accurate, complete, but also diverse with respect to age. And then we need to make sure that we are not only thinking about age, but that there is this intersectional kind of aspects where we are also focusing on differences between older people and gender and ethnicity, race and ability as well. I'll hand it over to Shehroz, who will now talk about some technological and some technical aspects and approaches on how we could also get over and start to address.
Thanks, Charlene. So I'll quickly, very quickly go through some of the technical aspects of how to handle if we have this type of data that Charlene has been talking about. So one of the most intuitive approach is called data augmentation, where you will want to include more data of older people. Now, one way is to actually collect the data. For example, these images, of older people may or may not be possible to extend in the existing data set. The other ways to do it algorithmically. But the problem with that approach is that it can lead to overfitting, because you are just seeing maybe very similar types of older faces. And we know, because of gender identities, ethnicities, and the way you are aging, that may not be a great idea. So data augmentation can help to some extent, but that is not really, and especially, using algorithms to generate more data may not be a very viable solution. Uh, but we can also take like a more participatory or a co-design kind of approach. So, for example, this work uh, by Park et al., where they actually collected data from older people, and they followed this core design framework, and they were able to, if you can see, they were able to collect a reasonable amount of data from people more than 60 years and older. um, I'm going to very quickly talk about two approaches and two my team is working on with Charlene and our graduate student. One of the problem was skin lesion detection, and so they had these images of skin of different people, different colors, ethnicities, and all. But and the task was to detect whether it is malignant or benign, whether it has cancer or whether it does not have. Now, on the left graph, you would see this is the training data. So this was the data that was available to train the AI models, and it seemed quite okay. In terms of representation, they had skin lesions from both younger and older people. But the testing data on which this model was supposed to be tested, it was severely skewed. It did not have, images from older people. Now, this is a problem because this is actually an apple versus orange problem. So you're training your model on apples and you're saying, okay, identify oranges, so any generic model will not work. And so we came up with an adversarial learning approach where in deep learning, I'm not going to talk about what it is, but what is important is this right figure on the right side. So the green triangle is actually the baseline model, and on the x-axis is MI, is the mutual information. The larger the number means more biased, and smaller the number means less age biased. And on the y-axis, on the vertical axis, is the performance. So you can see this baseline model actually did not perform too good in terms of performance, and it was heavily biased as well. And this efficient net ensemble model, which is state of the art, it performed really well, but it was highly biased. So what we did actually, we created this model that we're seeing on the left side, and what we showed is that we can actually control this bias, and because of the way this data was structured, our model was still able to show reasonable performance by while controlling this ages bias in the data, which I think was very, very exciting for us, that we may not really need super accurate models. We should not be chasing this accuracy, but we need to be cognizant and be aware of our models mitigating this type of bias or not. Second very quick example that I want to give it to you is, so this is another data set called the IMDb and Wikidata data set. And what this data set contains is, as you can see, images of celebrities and actors and popular people in the media. And it contains sports person and all that. So it is fairly we haven't analyzed it in terms of sex and gender, but it seems they have fairly good representation of men and women from different fields. But as you can see, this is heavily skewed. It only has images from people from 20 to around 45 or so. And the images for 50 plus people are very few. I mean, Harrison Ford just made, Indiana Jones, Meryl Streep, Morgan Freeman. There's so many older actors. Where are the actors who are playing your mom and dad and uncles and aunts, right? So why do we not have images of those great actors who are in the popular media? Christopher Plummer, there are so many names that comes to mind. So this is a very heavily biased data set. And so we're developing this another idea on supervised contrastive deep regression. I know it sounds very technical, but I actually looked at this problem more from a regression point of view, and our model, this SUPCR, what we call, is actually doing better. And this is the results from last week, and my grad student is still working on. So on the test side, we got better mean average error and a better Pearson correlation error. So so basically what I'm trying to say is that we can actually build models that can take care of this age bias and other types of biases, and we should not just give up. And we should be very, very cognizant of and aware while we're developing these models. So, Charlene, do you want to summarize this slide very quickly, and then we can end?
Sure. So like all other isms, including racism, sexism, digital ageism is rooted in pre-existing biases. And then our work highlights some of these technology-mediated cycles of injustice that represent this feedback loop, where we have societal ageist tendencies that leak into our methods, our design, our researchers, and then we also which then result in technologies that may not be well aligned with older adults or do a good job capturing the process of aging. And so then the resulting data from these technologies will then underrepresent or misrepresent older adults. Our review, our scoping review shows that there are large data disparities for older adults in very commonly used data sets, and that these machine learning models that are built from this data may not benefit older adults as much as younger groups. And so our research does indicate various technical options in order to combat some of these biases that Shehroz has talked about. And then the concepts of digital ageism and inclusion moving forward, I think, may be very helpful in helping us create a more equal and just world for older. To take questions. Ashley.
Sorry, I was on mute. I thank you so much, Shehroz and Charlene. That was super, super interesting. I'm going to invite people to put their questions in the Q&A. We do have one in the chat, which I will start with. So I have some, so I'll start with the one in the chat, and then I'll move over to the ones that are in the Q&A. Okay, so Amir asks, what is the argument when the representation of older adults is based on their population statistics? For example, if elderly comprises 18% of population, does 18% of their representation in AI would be enough for addressing the ageism?
Right. I mean, from a fair representation point of view, yes, this makes sense. Like, as long as you have proportionate amount of people, I think that's fine. So, you know, when you train a model and test a model, normally the distribution should be the same or similar. So this skin lesion example I showed is a very interesting example where you have fairly good representation of older people, but in the testing phase, that representation was skewed, and your algorithms that you have trained will not work properly. So it is important to you know, have sufficient amount of data. If it's 18%, you cannot say, oh, I mean, just you're done with 18%. I mean, it depends upon the problem also, but what we're trying to say is that the problems that you're trying to tackle, let's say age prediction or cancer detection or things like that, you need to have a proper representation of that population, of the age group that you're interested in.
And I think I'll add to that too. It's not purely about the proportion, because older adults, you know, they're not a homogenous group. So there's diverse backgrounds, experiences, needs. And so simply representing them proportionately to population statistics might overlook some of that diversity depending on how what data is being included. And so it's really, you know, we don't want to just say there's 18%, as long as our data set represents 18%, that's okay. Rather, it's about, you know, thinking more broadly around and more holistically around the complexity of age-related issues, and thinking about how some of those stereotypes might
Yeah.
come into play.
Exactly. And I always tell my students that do not, jump on the data. I think a lot of the problem with, people with computational background, engineering background is, they start with data. And that is a very wrong approach. There are so many things that we need to consider before collecting the data. What problem are we solving? What, like as Charlene said, older adults is a very diversified group. What kind of population you're targeting? Are they healthy older adults? Do they have any other cognitive problem? Do they have cardiac issues? So it depends upon. So you need to consider and think about your problem first before collecting the data. Because if you directly jump into the data, as we saw, it will carry over all those biases. So just collecting like, 50% older adult is fine is also not a good approach. You need to really sit and think about what problem you're solving.
And I think that goes
And I
back
think
to
I
one of
saw a
our.
question around how we can increase the participation of older adults. So
Mhm.
Charlene, do you want to address that?
Sure, yeah, I can do that. But just to add one more point to Amir's question is that again, it's not just around the proportion. It's goes back to our point about being more inclusive, right? So our research methodologies, the assumptions that we're making in how we are framing the problem, how we are evaluating the technologies, and so thinking a bit more broadly. And then the other question was about
Increasing
actually,
participation of older adults. Yeah.
okay, I actually don't see that question. Um,
It's just in it's in the Q&A. Charlene, so if you click on the Q&A tab, you'll see it. It's from Olive Bryington, who's one of our older adult and members of our older adult and caregiver advisory board. So just want to shout out to Olive. She's a big deal. She's beloved in this network.
I love it.
Check her out, guys, too. She's does some great work. Yeah, so she was asking, are there any ways we can increase the participation of older adults?
Oh, that's a great question. Thank you so much, Olive, for joining today. I mean, I think we need some, I think there's many things that we can do to increase participation of older adults. First off, I think having researchers recognize that we need to have older adults in the room, number one. So starting off with that reflexivity and that positionality, I think is really important. And, really just taking a moment to question how we are framing the problem and who is around the table to help us frame the problem. And then I think having champions like Olive, who are, national, treasures, who are then, such a good example of getting involved and the impact that you can make. I think there's a big gap between perhaps people who are designing technologies and having, that voice at the table. Shehroz, do you have any other comments around?
No, I think you said it right. I think it actually starts from the researchers, and a lot of education is needed. So in a lot of our work that Charlene and me are doing, we are actually utilizing or leveraging. AgeWell is a great resource. Whenever we have some co-design or participatory design thing is happening. So we reach out to AgeWell, and they have this great network. So it's just not researchers, but I think the ecosystem that supports that kind of approach. So we are very happy to be associated with AgeWell for a long time, and they have been very supportive. So if we have these kind of organizations within your institutes and university, I think that can also spread the message. So one person cannot do it. We need to have this kind of system in our institutes that promotes this type of engagement and dialogue, and so that people are more receptive. And whenever we talk to our patient partners, older adult partners, they're always very excited and very keen to provide feedback, and they provide very very nice insights, and that really inform us. Sometimes very minor thing that as an engineer I may not even think about it, right? So yeah, so it's, I think, development of a full ecosystem, full system that is supportive of this type of thinking. It's very important. Yeah.
We do have another question, but I do want to respect time as well. So maybe what I'll do to that person, that Arun, I'm gonna email your question to Shehroz and Charlene after the webinar. Um, and I'll put that answer in the when I send the webinar out for folks if they're interested in that response. So yes, thank you so much, everyone. We do really appreciate everyone coming out today. I really want to thank Dr. Shu and Dr. Khan for their amazing presentation of work that's very important right now, especially, you know, with a lot of us using Chat GPT and other forms of AI, which are becoming more popularized. It's really interesting to think about it, how AI is affecting our lives, but also, like you said, the digital ageism that's involved and how to mitigate that. So I'm excited to share this one with other folks that couldn't be here today. But I do want to wish everyone a lovely Thursday. And this recording will be out soon. And thank you again to Charlene and Shehroz. Thank you so much.
Thank you. Yeah, it was so nice to be here. Bye.
Thank you.
Bye,
You too,
everyone. Have a
Jen.
great day.
Bye. Thank you
Bye-bye.
for joining.